Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 6 to the power of x is equal to 9. Now what I'm first going to do is I'm going to take the log of both sides. So we have log of 6 to the power of x is equal to log 9. Now, if we have a logarithm in the form log a to the power of b, an important property of logarithms, also known as the power property, states that we can actually move this exponent to the front of the logarithm. So this would be equal to b times log a. So now I'm going to do the same exact thing to log 6 to the power of x. Now we can think of 6 as a and x as b. So I'm going to rewrite this by moving the x to the front of the logarithm. So now this would equal x times log 6 is equal to log 9. Now, to isolate x, I'm going to divide both sides by log 6 so that we can move log 6 to the other side. So now we have x times log 6 divided by log 6 is equal to log 9 divided by log 6. Now, for our left-hand side, these two cancel out, and we simply have x is equal to log 9 divided by log 6. However, if we have a logarithm in the form log a over log b, this is also equal to log base b of a. So we can think of 9 as a and 6 as b, meaning x would equal log base 6 of 9. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of x plus 6 to the power of x is equal to 9 to the power of x. Now what I'm first going to do is I'm going to start by dividing both sides by 9 to the power of x. So now by doing that, these two cancel out, and now if I have something in the form a plus b over c, this is equal to a over c plus b over c. So right here we have 4 to the power of x plus 6 to the power of x over 9 to the power of x, and that would equal 4 to the power of x over 9 to the power of x plus 6 to the power of x over 9 to the power of x. And this is equal to 1. Now, if I have something in the form a to the power of m over b to the power of m, this can be written as a over b to the power of m. So I'm going to use this property for both 4 to the power of x over 9 to the power of x and 6 to the power of x over 9 to the power of x. So now I'll have 4 over 9 to the power of x plus 6 over 9 to the power of x. And this is equal to 1. So now I can go ahead and subtract 1 on both sides. So now I have 4 over 9 to the power of x plus 6 over 9 to the power of x minus 1 is equal to 0. Now, I can simplify 6 over 9 here. 6 over 9, a common factor of these two is 3. So 3 times 2 would be 6, and 3 times 3 would be 9. So 6 over 9 would be simplified to 2 over 3. And now 4 over 9 here, well, 4, this is the same thing as 2 squared, and 9, this is the same thing as 3 squared. So I can rewrite this as 2 squared over 3 squared to the power of x plus 2 over 3 to the power of x minus 1 is equal to 0. Now remember, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So right here I have 2 squared over 3 squared, and this would equal 2 over 3 squared to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And notice how n and m are interchangeable because they are multiplying with each other, meaning a to the power of m times n is the same thing as a to the power of n times m. And if this is true, then this must mean that a to the power of m to the power of n is the same thing as a to the power of n to the power of m. So right here, I have 2 over 3 to the power of 2 to the power of x. And I can think of a as 2/3, m as 2, and n as x. So now I can switch the places of these two. So this will get me to 2 over 3 to the power of x squared. So now going back to the original equation, I have 2 over 3 to the power of x squared plus 2 over 3 to the power of x minus 1 is equal to 0. Now I can let 2 over 3 to the power of x equal to the variable y. So now if I substitute in y for 2 over 3 to the power of x, I get y squared plus y minus 1 is equal to 0. And now, as you can see, we have a quadratic equation. And any quadratic equation can be solved by using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So the coefficient in front of y squared is 1, the coefficient in front of y is 1, and we have negative 1 over here. So this means that a is 1, b is also 1, and c is negative 1. So now if I plug these values into our quadratic equation, I get negative 1, because negative b, plus or minus the square root of b squared. So 1 squared minus 4 times a, which is 1, times c, which is negative 1. And we are dividing this by 2 times a, which is 1. Now this is equal to negative 1 plus or minus the square root of 1 squared, which is 1, minus 4 times 1, which is 4 times negative 1, over 2. 2 times 1 is 2. And this is equal to negative 1 plus or minus the square root of 1 minus 4 times negative 1 is negative 4, so I have negative 4, which is positive 4. Over 2 is equal to negative 1 plus or minus the square root of 5 over 2. So now this gives me two values of y. I have y is equal to -1 plus the square root of 5 over 2, and I have y is equal to -1 minus the square root of 5 over 2. So remember how we set y equal to 2 over 3 to the power of x. So now we have 2 over 3 to the power of x is equal to, let's start with -1 plus the square root of 5 over 2. So if I solve this, I'll first take the log on both sides. So I have log 2 over 3 to the power of x is equal to log of -1 plus the square root of 5 over 2. Now I can divide both sides by first, before I do that, I can move this x1, x to the front of the logarithm. So now I have x times log 2 over 3 is equal to log -1 plus the square root of 5 over 2. Now I can divide both sides by log 2 over 3. So then these two cancel out, and I would have x is equal to log -1 plus square root of 5 over 2 over log 2 over 3, which is equal to approximately 0.87.